first question I see, Niko, that you sent over here. Perform the indicated operation, use the fundamental identities to simplify this. So a couple things here, like this 96 is in both of these on the right. So it's, let me do it this way, 96 cosine x over 1 plus sine x plus 96 times 1 plus sine x over cosine x. And these both have a 96, so you can factor it out. So your answer is 96 times whatever we come up with for this other part, the cosine x over 1 plus sine x plus 1 plus sine x over cosine x. So I'm drawn to this 1 plus sine x. That's sort of the harder thing to deal with. So I'm going to multiply by the conjugate, and that's kind of a standard thing in these problems. Jamie, do you have a similar problem, or did you already solve this one?
Mine's very similar.
Okay, so this becomes cosine x. Well, actually, let me not multiply the top. That's the correct strategy. So it's 1 minus sine x times cosine x, and on the bottom you get 1 minus sine squared x, which we know is a Pythagorean identity. It's sine. It's cosine squared x. This is really cosine squared x, which means that one cancels with that one. And now you have a common denominator. Like you didn't have it a minute ago, but now you do. And that's how these things kind of work themselves out pretty nicely. So you add the numerators. Well, the signs cancel, and you're left with 2 over cosine x. And then you still have that 96. So it's 192 over cosine x. Could also write it as, I guess, 192 secant x. Niko, anything you'd like me to go through again on that one?
So when you have the conjugate, just remember, like, you don't multiply the top, right? You just kind of leave it as 2.
Yeah, and that's something you learn from experience. So yeah, you always multiply the bottom. Like if it was 1 plus cosine, you do 1 minus cosine, or 1 minus 1 plus,
Okay.
but you don't multiply at the top. If you do, you have to remember to factor it out later, which I was about to do, and then I remembered, oh yeah, you don't do that on these, but
Okay.
yeah. Jamie, any questions on that?
Nope, that makes sense.
Okay. So Jamie, you sent over your first problem is like way different part of the course than first one, the pilot thing. We can definitely get to those, but let me do, I guess, a few more of these other ones.
That works.
So let me grab 16 first. I think it's 16. Is this like a final exam review, or is it just old homeworks? What are we looking at here?
That should be just final exam.
Okay.
Yeah.
All right. So when I see a problem like this, rewrite the expression in terms of the first powers of the cosine. So we got to do it just in terms of cosine. Just in terms of cosine. So this is very much your trig cheat sheet stuff. And I'm going to pull that one up that I always pull up from Lamar. I'll send you guys the link in case you don't have it handy. But if you don't know the formulas, you have no chance. You know, it's like showing up to the game, and you just can't even do these problems. So there's 3 forms of double angle formulas. And there's 3 forms of the ones that we want, which is the cosine. So what I mean is, like, there's 3 here that you have to know. Now they all stem from the first one, so you can build them from this if you wanted. But basically you need to solve the second two, if you had this handy, you need to solve the second two for the one that's squared. So the cosine squared, this first one, you add 1, divide by 2. So instead of this right here, you get cosine 2 theta. So really it's 2 times this x over 2 plus 1 divided by 2. So that reduces to cosine x plus 1 over 2. Yay. This next one here, sine squared, we get from this other one. This one a little bit, you add and then you subtract and then you divide. You get, I'm sure you can see that algebra there, but it's 1 minus cosine 2 times x over 2 over 2, and then you got this 9 that comes down. So that's 9 over 4, 1 minus cosine x times 1 plus cosine x. And so that gives you 1 minus cosine squared x times this 9 over 4. And that's no good because now we're back to the same problem we had, which is that we can't use that. So you have to go back and reuse this one that we first used, this second line here, the fact that cosine squared theta equals cosine 2 theta plus 1 divided by 2. So instead of this cosine squared theta here, we're going to go 1 minus cosine 2x plus 1 over 2, 9 over 4 out in front, like that. So this is correct. It may not accept this because you may have to like simplify, but I think WebAssign will. But since you guys are worried about your final exam, you've got to decide, more importantly than this is these double angle formulas. Like, are you going to remember them all? For sure, the first one you got to remember. And actually that you could have used the first one to kind of start out here. I think it might have actually saved you a little bit on that. But these are sometimes called the reduction of power formulas. Reduction of order. I'll take no feedback as there's no questions on that. Okay. All right, so let me grab the second question here from Niko about circular blade on a saw. All right, so the circular blade on a saw has a diameter of 7 inches and rotates at 4,500 revolutions per minute. So the angular speed is radians per second, and all this really is a units conversion problem now. So that in 1 minute there are 60 seconds, so that takes care of that. And the radian part, 1 revolution is 2 pi radians. So 4,500 times 2 pi divided by 60. Niko, will you confirm that that is the right answer? Because there's a small little thing here that I want to make sure I'm not missing.
Yeah, I'm gonna type it.
I get 471 roughly, if you don't have a calculator handy.
That's right. That's correct.
Okay, Jamie, do you have this problem? Do you have similar numbers? Is it clear what to do?
Yeah, I did that one.
Okay, so notice we did not use this. So the linear speed V equals RW. So I think you take, gotta remember this. Spins up, yeah. I think you take the radius, which is 3.5, and you multiply it by the number you just found in the previous problem. Unless it's something different. But I think that's right.
Yeah, I think so.
Did that work, Niko?
Putting it in right. Yes, yes.
All right. Are you guys allowed a reference sheet on your exam?
We're
We're
given like a
one.
final formula type of thing. It's like I can show you.
There's some of the
Okay.
formulas.
It has like all the like parabola conic stuff and then some double angle and other stuff.
Yeah.
All right, Jamie, so out of like 15, 17, do you have a preference?
Can we go over 15 first?
Sure. This is awful. Yeah, it's one
Yeah.
problem, but it might as well be three. They're not all created equal. All right, so the setup here is to figure out like where you're at, which quadrant you're in the unit circle. Now it tells you, which is helpful. You do have to be able to draw the right reference triangle, which is very important here. You're in the fourth quadrant, so this is your reference triangle. It's very important that you draw it in the correct orientation, and theta is always the angle with the x-axis. Okay, so now cotangent is -7 over 1. I don't really know cotangent. I know tangent because that's one worth remembering. And it's the flip of this. So it's either -1 over 7 or it's 1 over -7. We'll figure that out here in a moment. Tangent is opposite over adjacent. So opposite 7, 1. Which one has to be negative? This one here. You got to find the
Okay.
hypotenuse most of the time. That's -7 squared plus 1 squared. So that's 50. 50 reduces to 5 root 2. So you always have to find the hypotenuse.
Okay.
So for the rest of these, you need that reference thing that I grabbed earlier. So the sign of 2u, that's the easy one. It's 2 sine u cosine u, and you just, and relatively easy it's compared to the other ones. You take the values. So it's 2 times sine of theta is -7 over. So you could do this. You could also use a square root of 50, I guess, because you are going to multiply. Cosine u is 1 over 5 root 2, because now I've sort of made it more work to reduce this, because the bottom is square root of 50 times square root of 50, so it's 50. This is -14 over 50, and I don't know. I don't know if it'll accept that. You may have to reduce to -7 over 25.
Okay.
Cosine. Oh, I'm sorry. Niko, you have a similar problem, hopefully, where yours is -7.
Mine's
Some
negative
number
2.
different than that.
Yeah.
So that the only thing you're going to change there. Well, it changes. Let me draw your triangle, because that will. Yours is -2, so that's the square root of 5 here. All right, and then that just changes the numbers in the bottom there. So let me know if you have any issues with getting the right answer on that. But you can almost just see where your numbers change there and down there. All right, cosine 2u. I'm gonna go 2 cosine squared u -1. So that's 2 times, and then that's yet another reason not to rationalize this, because when you square it, it goes back to the original. So cosine was 1 over square root of 50 squared -1. So this becomes 2 over 50 minus 50 over 50, which is -48 over 50. which is minus 24 over 25.
Okay.
Please tell me if these are not right.
Yep.
Yours, Niko,
Mine
is
was right.
1 over square root of 5 squared, whatever that is. And then tangent's kind of interesting. You see there's formulas for tangent. You never, in that thing up here, probably here it is. Oh, so there's a formula for tangent. You never use tangent formulas unless that's the only one they ask for, because the better tangent formula is cosine over sine. And you'll notice they have the same denominator. They're supposed to. That's very helpful. Because then it becomes minus 24 over minus 14. Just take your previous two answers and divide them like that. All right, so Niko, you got kind of some you said exam review questions here. I'm gonna pull up next. Is there a calculator versus no calculator part on this exam?
All of it's calculated except for like verifying trig identities. So
Okay, is it
it's
like multiple
mostly,
choice or is it or is it like
35 multiple choice and then 3 verifies. And multiple choice is all calculator.
is this over 2 on the bottom?
Let me check. I can't even see it. It's on the
I
computer.
mean, it
so
most
they-
likely is, but I
yeah.
don't know. I don't know if it's negative either. So the reason I was asking about the calculator stuff is you can go to your calculator and type, I think it's negative here. You can type in arc sine square root 3 over 2. And if you do this when your mode is in degrees, either one of you have that handy.
Yeah. I think that's degrees.
Let me know if you get a number.
60.
60 degrees, okay? So the truth is that's correct. Arc sine is only good from pi over 2 to minus pi over 2 to pi over 2. So that's your answer right there. If you wanted it in radians, you can multiply by pi over 180. There is really no work here. If you did have to show work, you have to do this. You have to make a substitution. You have to let theta equal this, and you have to draw a triangle. But I think you can just give the answer.
Yeah, I think so for the test.
And I know it says, that's why I keep asking you. That's why I was asking about the calculator stuff. It's like, well,
Mhm.
13 is kind of the same way. You just put it into the calculator and you'll get 45 degrees and you're done. And if they
Quick
want it in
question.
radian, yeah, go ahead.
So our exams gonna be multiple choice. Is there any like strategies to like use the answers to find it faster for any of these?
Yes, I mean, if it says which of the following, you have to use the answers, but do you know how much time you have? You said 35 MCs. How much time do you have?
Like
Like an hour and 20.
an hour
30.
and 20, yeah.
80 minutes. So, and you said 3 free response.
Yes.
Yeah.
They're all
It's like-
verified too.
Yeah.
Okay, so like some quick math, you get 2 minutes each on them MCs. That gives you 10 minutes for the free responses. It's a little tight. I mean, yes, the answer is yes, but is this like a common final or is your instructor writing it?
She wrote it.
So my guess is based on what I've seen in the past, the questions are going to be very difficult to use the answers. They will take you longer than just
Mhm.
trying to directly solve. You might
Okay.
be able to eliminate some.
Okay.
And you know, like really quickly here, if there's 4 answers,
Yeah.
and let's say you eliminate D, and you do A and it's wrong, and B and it's wrong, what is the correct answer?
C.
Do you have to check C?
Probably not.
No, you shouldn't. So if you're really into saving time, you have to use the correct time saving strategy, which is not to like like verify because you want to feel good about it is to say, well, no, 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 yes. And that
Okay.
will save you the time. But from what you guys said, and other things they can do is they can really nuance the answers to make them all kind of look right and not give you enough information to eliminate any.
Mhm.
Now at your school with the general finals, they are terrible at their multiple choice, so you can eliminate 2 answers pretty quickly. It's kind of rough. I mean, I don't see this problem on your there because it's so easy. You just plug in a calculator if you have one.
Yeah.
And do it.
Okay.
So I don't know if that answers your question. I mean, multiple choice is a huge kind of thing to talk about.
Yeah, no, that helps. Thanks.
Okay, so this one you do have to draw. You cannot just, okay, you could go to a calculator with this, but I don't think you'll get an answer that's reasonable. So when you get something that's unreasonable, you got to go, okay, let me work it backwards. So what you do is you say let theta equal arc cosine of 12 over 13. You take the cosine of both sides, which undoes the arc cosine part of it. So you get cosine theta equals 12 over 13. You can absolutely shortcut to what I just did there, but that's the full work. So you draw a triangle. Here's cosine adjacent over hypotenuse. This is a Pythagorean triple, so you can quickly get the third side. And now instead of sine of arc cosine, this is really theta because that was our substitution. So sine of theta is 5 over 13.
Mm.
Now, if you plug this into your calculator, you may have gotten 5 over 13.
Yeah, it does get that.
Um,
That one you just happen to be able to shortcut.
yeah, so some of them you can.
Okay.
What I would be concerned about is if like, so a few things I'll mention here is A is the most common wrong answer on these things.
Mhm.
And the reason is they're often the intermediate or they're like missing something. Like, let's say this is a bad problem, but let's say we were going to use this number in something else, that would be A. If I asked you where sine of theta equals square root of 2 over 2, the correct answer is pi over 4 comma 3 pi over 4, but answer A might be just pi over 4.
Mm.
And down in letter D is pi over 4 comma 3 pi over 4. So you really want to scan the entire answer space before you just, bubble it in. Really think, especially if a human is making it, because they think about these things. It's a computer, it's totally different. All right, Jamie, I'm going to jump back to your stuff there. Niko, if you got some other questions, please queue those up for me. So do you want us to do like 17 or 19?
17
Like
works.
We did. I remember doing 19 also in another lesson with you. At least it feels like that. But here we go.
might have.
17. Here we go. All right. Use the half angle formulas to determine the exact values of the sine, cosine, and tangent of the following expression. So your angle is 165. So you need to double it. It's 330. And so we need to actually go and grab our formulas, which you said you're maybe going to be given. I wasn't clear on if you're going to get these. You said some conic sections.
I think the double angles are on there.
Yeah. So theta is 330, not 165, because 330 divided by 2 is 165. So the sine of 330 divided by 2, which is 165, is this first one here. It is plus or minus square root 1 minus cosine of 330 over 2.
Okay.
So cosine of 330 is on your unit circle. That's 30 degrees left here. It's very similar to 30. So if that helps, I mean, if you got a calculator, that's another thing you guys should do. You should know the decimal equivalence. So root 3 over 2 is 0.866. root 2 over 2 is 0.707. You might even want to learn root 2 root 3 over 2. That's the only ones. Or sorry, 2, oh, it's over 3. There's a few others to remember, but that'll help save you from having to like do it by hand. If you don't want to memorize the unit circle, you can memorize what their decimal equivalents convert to. So cosine 330 is root 3 over 2. So it's plus or minus square root 1 minus root 3 over 2 over 2. So this is 2 over 2 in here. So it's 2 minus root 3 over 2 over another 2, 2 minus root 3 over 2 square rooted plus or minus. The way you figure out whether it's plus or minus is you go back to the original angle, which is where you are, and you figure out which quadrant you're in. Which quadrant is 165 in? Quadrant 2. So there you know that sine is positive. So we would choose the positive here on this one.
Okay.
A lot there. The other thing is, I'm sorry, this is over 4, not 2. Sorry about that. Your instructor probably would expect you to take the square root of the bottom.
Yeah, probably.
Probably. Niko, oh, and then you got to multiply by 5. So you just take this and multiply by 5 as your final answer on that one.
Okay.
Now, nicely, cosine is really similar to sine. It's just plus instead of minus. And notice we didn't really do any, we didn't combine anything. So it's just 2 plus for cosine. But cosine in the second quadrant is negative. So your cosine of theta over 2 is negative 5 square root 2 plus square root 3 over 2.
Thank you. Okay. Yep.
Tangent is the last one. And again, you have a choice. I don't know what they'll accept. And that's a good like multiple choice thing is you can give it in a way where you don't really recognize that it is the right answer. That's another sort of like thing they do to make it more difficult. So you could just divide your two answers here. This one divided by this one, which is 5 root 2 minus square root of 3 over 2 all over minus 5 square root 2 plus square root of 3 over 2. So notice the 5s cancels, the 2s cancels, and you do have a negative. You cannot really reduce this. It just looks bad. And it's the same for both of you because that number out in front just cancels out. You could use the formula, the 1 minus cosine theta over 1 plus cosine theta inside the square root, but you will get the same thing.
Okay.
Another, again, like this could be presented, you could write it, this could be the answer. This is also correct. These are both correct, but what if your instructor gave you like 2 minus there? That's a bad example. Maybe they put minus plus, and like you didn't realize, oh, I gotta just rewrite the root.
Yeah, that's not fun.
Yeah. All right, Niko, do you have some other stuff? Oh yeah, you sent something over. Great. All right. So 7 is a great example of like a problem where they don't define the interval. So you could have more than one solution, but let's see what we got here. I think your instructor wants you to replace tangent with the double angle formula, or I'm sorry, the half angle formula. So it'd be the square root 1 minus cosine x 1 plus cosine x minus sine x equals 0. And this is by hand.
Yeah.
It's Sorry, I'm gonna graph this because I don't know if that even is even reasonable. To do by hand. All right, well, I guess it does work. This may not be the right path. Trying to think of how else to suggest doing this. Because this would involve like moving this over and squaring both sides. And when you look at the graph, the answers are somewhat nice. What we're looking for is on the unit circle where half the angle gives you the same value as that one. So like, for example, well, we'll start with 0. So at 0, tangent of 0 over 2 is 0 and sine of 0 is 0. So the next kind of like interesting one is tangent of pi over 2 over 2, which is really pi over 4. That's 1. And sine of pi over 2 is also 1. And then similarly, if you go tangent 3 pi over 2 over 2, that equals -1. Sine of 3 pi over 2 is -1. And then 2 and 2 pi, 0 and 2 pi repeat. So these are your three answers, but it does repeat like 2 pi. And then also at the other places. There's not really a good way to solve this one by hand, because this half angle formula doesn't work great. If we converted sine to a half angle, that might do something. Just looking at the formulas again here. It's kind of an interesting problem. Kind of. Yeah, I think this is like more of just a unit circle understanding thing. I don't have much more to say on that. Do you guys have any ideas or anything come to mind when you see that?
No idea.
No.
Okay. Yeah, but you see it works. You see that there are nice values. So like maybe the thing to take away from this problem is that sometimes you can just go to your unit circle and look for things like that. The other problem here is a lot like the one that we did where you make this theta. And so your cosine of theta is x over 3. And then this becomes 9 minus x squared using your Pythagorean theorem. So then the tangent of theta is from this right over here. It's this like this. This would be a good Jamie multiple choice thing, because like this is the correct answer, but I could just as easily put this as the correct answer.
No, it just flipped. Yeah.
Just flip. I can do other things like put 3 here. Let's just say this was the right answer, not for this problem, but I could also present it where I rationalize like this. These are equivalent. I don't know. I'd have to see more of your teacher style to give you a better, more in-depth answer on that. Niko, I went through that fairly quickly. It's like that one where it's the 12 over 13. Is it clear how to draw the triangle and you make the substitution? Okay. Yeah, because there's two types. There's with numbers and then there's ones with variables.
Okay. Thank you.
All right, Jamie. So you have I think we've got like 19 is the next one. Is that right?
Yep. That is the last.
Yeah. Pilot. I'm not gonna copy this in.
Okay.
It's the picture. Niko, yours probably the only difference is gonna be. Oh, you have different angles. Darn. Okay. All right. So the I guess the idea is there is the first thing. There's an 11,000 foot runway, not to scale here, and then there's a angle to here, there's this angle. And then there's the other triangle, which is to the ends of the runway, 16.3 and 18.6. So then this is, let's call this X. This is 11,000 plus X. And we just got to get the angles right. So this angle right here, trying to think. So the steeper angle is the first one. So this is 18.9, the steeper one, the larger one. And this is 16.3. Reason I'm doing them down there is because the ones at the top are useless. You have to get that other one. They're the same. Through
Oh yeah.
parallel lines, transversal. So your elevation equals your depression angle. And we don't know the height. Is that right? We do not know the height. Just make sure not that's it. Okay. So here's the height. Here's the height. We can make two equations, two unknowns. The first one is the tangent of 18.9 equals h over x. The second one is the tangent of 16.3 equals h over 11,000 plus x. If you had a calculator, you guys have TI-84s?
Yeah.
I know that there's a Numeric Solver. You guys tried using that?
What do you have to do to
Alright.
get it?
I don't remember where it is, but you let YouTube guide you, but you enter this into thing one, thing two, you make a guess, and it'll give you, you have to solve each equation for like h, but it would solve these for you. To do it by hand is a little clumsy, but we can do that. So I'm gonna solve this one for h. So h equals x tangent 18.9. And then let's put that into this other equation here. So tangent 16.3 equals, let me just say tangent 18.5 x tangent 18.5 over this 11,000 plus x. So you multiply the left side by this 11,000 tangent 16.3 plus x tangent 16.3 equals x tangent 18.5. You move the x term to the other side, and then you factor out your x. So Niko, it looks like your problem, the only difference at this step is you're putting your runway length there, larger angle, smaller angle there. And then you divide. Make sure, oh, this is very important. If you are using your calculator, always check your mode between radian and degree. That's another thing they could do is put the correct answer, put the answers if you had the wrong mode. So just, really make sure, am I in degrees or is it really radians? Okay, so once you get that value, you put it back in to get h. But I think the like letter B wants x. C is, oh no, sorry, C is x. D is h. And then the this hypotenuse you get, you have to do the square root of h squared. That's, I think that's the air distance is this. Excuse me. And then x is the ground distance. And then h is the altitude. Yeah, a lot of work.
Yeah.
And like, one way to, it is, I mean, maybe you only get part A, I don't know, maybe you get part where you just gotta find X, maybe that's how you make this more manageable. But 2
Mhm.
minutes is pretty quick. University of Arizona gives you 3 minutes on their math common multiple choice exams, 3 minutes per question. Still not enough time for most students to try and use that approach of trying all the answers.
Mhm.
Maybe save that for a question where you're really, really stuck.
Yeah.
I wouldn't use that as a general strategy. All right, we got a few minutes left, guys. Is there something else you'd like us to cover tonight?
I have one more problem.
Okay, go ahead and send it over if you haven't already.
Yes, I should think I sent it.
Have you guys done your grade calculations to like know you need this to get this?
Yes.
Yeah, all that
yes.
sorted out. Okay,
Yeah.
all right. All right. Perform the operation. Blah, blah, blah. Okay. Okay, cosine 40 plus I sine 40. 13 or 29 cosine 25. There are these like, well, so like I'm tempted to just tell you to FOIL. I feel like though I might be missing something. But it would be, you would get so the 13 over 29 and this 1 over 22, I think you can just put off to the side for the moment. And so it's cosine 40 plus I sine 40. And this is e to the I theta. Do you guys like see that in class? Maybe.
Um,
I don't remember.
don't
Okay.
Do we, Niko?
Never mind.
I don't know. Not sure.
Okay. All right. So the next step here is to FOIL. You get cosine 40 cosine 205 plus I sine 40 cosine 205.
Mhm.
And then then you get this other one here, cosine 40 sine 205, but it's got an I with it. And then you get the last one, which is I squared, which is -1. So it's negative sine 40 sine 205. So these are double angle things, not double angle, product of some things. Let's see if I, or sum and difference. Sorry. So the first one, cosine minus sine sine. So this one is cosine 40 plus 205. So it's 225 plus I. Sine cosine sine is sine. We're adding this time, so it's also signed. That makes sense. That's what I was asking about this thing. It's called Euler's, one of Euler's theorems. Another old math dead guy. And then
Yeah.
you can reduce these. So this is a minus √2 over 2 plus I. It's negative again because you're in the third quadrant. And then you can multiply by these coefficients if you need to. Very briefly, the reason this is so important is because this is e to the I 40 times e to the I 225. And when the bases are the same, you add the exponents, so you get e to the I 2, sorry, this is 205. Sorry. Did I gave you the wrong, this is 245, isn't it?
Oh yeah.
Sorry. So these aren't right, but 245, you just apply the formula again. I think there's something else going on this. You guys might want to check some online resources.
Okay.
But it produces this line. without having to do all this double or product to sum business
Got it.
on that.
Okay.
All right, well, that probably is it.
Mhm.
Thanks for letting me help you guys. I'll be available again in the future if needed.
Okay.
Thank you.
Thank you.
Have a great summer. Talk to you later.
Too.
Bye. Bye.